Hello, welcome back. We're going to continue working with square roots that involve variables. These problems will be a little bit more complicated, but as long as you take it one step at a time, they will all be very familiar with the way in which we solve them. So the first one is 54 times x squared times y cubed. And now we want to take the square root of this entire guy here. So when you see a square root that involves numbers and variables, we just write the factor tree out as you normally would. So let's go down here. Let's handle the numbers first. What times what gives you 54? Well, 9 times 6 gives you 54. And we'll break that down a little bit later. What about the x squared and the y squared? Well, the x is going to be, or the x squared is going to be x times x. And then we have y, which is going to be y times y times y. And all this stuff is multiplied together. All right, now let's look at the 9 and the 6. The 9 can be written as 3 times 3, and the 6 can be written as 2 times 3. So now we have everything broken down into its kind of its lowest form. We can't simplify or break it down into more simple factors. So now we start circling pairs. We have a pair of 3's, a pair of x's, and we have a pair of y's. This 2 does not have a match, this 3 does not have a match, and this y does not have a match. So we're done with that, and we can start to construct the answer. Now, from this pair of 3's, a single 3 can come out of the radical. From this pair of x's, a single x can come out of the radical. From this pair of y's, a single y can come out of the radical. And everything else has to stay under the radical because they don't have pairs. So what you have is the 2 times 3 times y is basically going to stay under there. And so you're going to have 3xy times the square root of 6y. That's going to be what's left. That's going to be the final answer. So you follow it formulaically. You're doing the same thing over and over again. Now we're going to do another one here, but this time we'll make it a little interesting because it'll be a fraction. 100 times x to the 10th power divided by, or a fraction with, 121 would take the radical or the square root of the entire thing. Remember how to handle this is what we break it into numerator and denominator. So we'll have 100 times x to the 10th. We'll take the square root of that guy, and then we'll divide it by the square root of 121, like this. So we have 100. Let's work on the first one first, the top, the numerator. We have the square root of this. We need to write a factor tree. So you need to be smart about this because you have 100, which you can write lots of different ways, and then you have x to the 10th, which you can write lots of different ways. So let's go ahead and write it as 10 times 10, because that's the easiest way to make 100. That's a perfect square. I could write it as 2 times 50, but then I'd have to break the 50 down and so on. It's just nicer to write it as 10 times 10 because now I have a nice pair. I can just stop. I don't have to go any farther.